Okay, we're talking about measurements. Now, there's a couple of different things, and this is probably some notes for you to write on your notebook paper, not on mine that I gave you just a minute ago, on your notebook paper. There are two different measuring systems that we talk about. Okay? The first one is what we call customary system, and this is United States does this one. Okay? And this is what we prefer in the United States. We're talking about inches, feet, okay? Those are the U.S. customary, all right? Inches, feet, okay? Then we also have a metric system, okay? The metric system is what other countries, okay, will use around the world. Okay, so sometimes if any of your parents do construction work or have tools, sometimes they have things that are different, like if you use a socket wrench, okay, and they have those different attachments. Sometimes you'll see things, using just your normal inch measurements, and some you'll use your millimeters and centimeter measurements. Those are the two different types of measurements. So sometimes they have tools, okay, and they don't match up sometimes, not exactly. Okay, so sometimes you'll see them go from one to another because it doesn't quite fit up. Okay, but those are the two measuring systems that we're going to talk about. And we're going to convert between the two. Okay, now, when we convert, it's an estimation, it's an approximation. So those do not mean exactly equal to. Okay? So remember that when we do these conversions, I ask you how many centimeters are in an inch. Okay, you're giving me an approximation. We can't exactly pinpoint. Okay? Well, we're not going to ask you to exactly pinpoint. Okay? There are calculators out there who can give us, but it can take us out to several decimal places. Okay? So we give an approximation, an estimation. Okay? Not exact. Okay? All right. Now, on your measurement sheet, so go back to your measurement sheet that I gave you that looks like this, and we're going to fill these in. Okay. Customary. Okay, that's what we use in the United States. So inch, 1 inch. See that little squiggly line under metric? Like this? That means approximately. Okay, if I meant equal, I would have used the equal sign, right? Okay, so I'm not telling you it's exactly equal. It's as close as I'm going to get, okay, to what I need. So 1 inch is equal to 2.5 centimeters. Okay, and we're going to have to know these. Okay, got to know these. All right, my next one, 1 foot is approximately 30 centimeters. No, the symbol's already on your paper. Okay, 12 inches, because 12 inches is a foot. Okay, and that's approximately, not exactly equal, but it might be 29.98888. Okay, so it's as close as I can get. So I'm just going to go up to round to do a 30. Okay, all right. A little longer than blank is approximately inches. 1 meter. So a little longer. Okay, so 1 meter. Everybody see under metric has 1 meter. A little longer than, well, a yard, which is about 40 inches. So under, I probably needed to scoot mine over. So let's do this. I'm just going to scoot ahead. So under metric, I have approximately 2.5, approximately 30. And this was under customary. So my first one that I'm going to fill in under customary is it's a little longer than a yard, okay, or about 40 inches. That's a meter. Okay. Yes, we have a customary column and a metric column. A mile. 1 mile is about 1.5 kilometers or kilometers. That can be said both ways. Different people refer to it both ways. Kilometers or kilometers. The next one down says, I'm going from metric back to customary, 1 kilometer is equal to, see, I don't like that one, because up here I said 1 mile is about 1.5. So we're going to actually change that one, okay? Oh, they did the conversion backwards. Hold on one second then. 1 kilometer is slightly farther than half a mile. So approximately half a mile. Let's see what they did now. Okay. Then we have 1 ounce is equal to 28 grams. That was 1 ounce. 28 grams. Two pounds. Okay, 2 pounds. And the symbol for pounds is LBS. Or I think they wrote it, actually. They did. They wrote out pounds. It's a kilogram. It's just a little more than 2 pounds, but we're going to estimate at 2 pounds. 1 quart is a little less than a liter. Okay? So it's just a little less than a liter. And 32 degrees Fahrenheit is 0 degrees Celsius. Yeah, degrees is that little circle right there. Now, there's a difference, and they're going to give you a definition at the bottom between weight and mass. Okay? We talk about our weight. I get your height and weight every year. Okay? We talk about how heavy something is. That's the weight. Okay? Weight, and they've already filled it in, it's the pull of gravity on the mass of an object. Okay? That's the gravitational pull, okay, from the Earth, okay, on each individual person. Okay? Now, mass is the amount of matter in the object. Okay? So there's a difference between weight and mass. Now, since the mass of an object remains the same regardless of its location, the weight of an object changes depending on the gravitational pull at its location. Think of the people who go to the moon, and you see them floating. Do you think their weight changed? Their weight didn't change, but their mass. Their mass didn't change, but their weight changed because of that gravitational pull. There's no gravity out there pulling them back down. Okay? So, I know, yeah, he totally said the opposite, okay? So the mass does not change. That person is still made up of the same matter they were on Earth as when they went to the spaceship and went to the moon. But the gravitational pull is different there. So therefore, their weight is different. Okay? All right. Water freezes at 0 degrees Celsius and 32 degrees Fahrenheit. So you're going to actually put both of those on there. So at the bottom where it says water freezes, 0 degrees Celsius and 32 degrees Fahrenheit. And those two are the same. What, the little circle? Freezes. Like when you put water in the freezer and it turns to ice. Z. Okay? The next one, it says water boils at 100 degrees Celsius and 212 degrees Fahrenheit. Okay, so when you think about it, when somebody gets burnt, like scalding water, they knock a pot over on them and they get burnt. That's 212 degrees touching your skin. Well, now when you get into burns, there's a first, second, third degree burn, and it depends, okay, on the layers of skin that it goes through. Okay, that's how they base your degree of burn on.
So if you were like, if you put water in one of those little kettles that whistle, is that like, that boiling water?
Yes, when it whistles and it causes steam, okay, then it, okay. Actually, let me stop this for a minute. What happened? Who can tell me what this represents? Oh, everybody agrees with that, right? Okay, let me ask this question. What if I only used words? It's still one hole, as long as this is 1 inch and this is 1 inch, right? Okay, they kind of cancel each other off. So let me ask this question. If you had 4/2, and I just asked you to reduce that as a fraction, I don't want a whole number, what would you do? Okay, reduce by 2, and I would become 2/1, right? So I reduce. Now, what you're going to end up doing, though, because I asked you to keep it as a fraction, okay? We're going to do that with the same thing with words. Okay, so let's look, and you may want to write this down. If I have inches times centimeters over inches, inches is on top, would you agree? Inches here is on the bottom. So what can I do to my fractions or my words when I have one on top and one on bottom? I can cancel out. Now, so because I have an inch on top and an inch on the bottom, those cancel off, and you're only left with what? Centimeter, and it's on top, correct? So let's look at another set of words. Let's say I have feet. That's my pen, all right? And I have inches and feet. Feet's on top, feet's on bottom, so what happened to these two? They cancel off, and you're only left with inches. Let me see how I did that. I can do the same thing with yards and meters and yards. So what's going to cancel off? Yards, because one's on top, one's on bottom, and I'm left with meters. Yes. Yeah, okay. Good question. What if I have a yard on top and I'm multiplying by a yard on top? You guys have kind of already done this. What happens when you have 2 times 2 and I ask you to use exponents? How do you write that? 2 to the second power, or 2, is that other word? Yes. 2 squared. 2 squared. So now when I have this, we really don't say y to the second yard to the second power. We say square yards. Okay? Which is the same thing. Now when you see it written, it's like this. It is with the 2 power. But we read that as square yards. We can do that with feet, square inches, whatever my unit is there if I have 2 of them. So what do you think is going to happen if you have 3 of them? What? Now let's think about it. Am I going to say yard 3? Cubic yards. And we know cube or cubic means 3. Okay, now after 4, we don't have 4, and we don't really go into measurements of 4, but let me explain. When you have square, okay, square units, when I say units, units could be my inches, my feet, my yards, whatever. We're usually talking about area at that point. Okay, we're talking about area. If we can say cubic units, we're talking about volume. We're filling a container. Area is we're going to cover the floor in here with carpet because it's length times width kind of stuff. So we're just doing an area. If I wanted to bring in a bucket of water and fill this room with water, then I'm covering volume. I'm doing length, width, and height because I want to fill the room with water. Okay, so that's a volume. What's your question? Okay, but no, because 2 times 2 is 4. Okay, but I just wanted to use it with my exponents when I asked you to write that as an exponent. Okay? Alright, so here's what's going to happen. You remember when we were multiplying fractions, or we were adding fractions, and we said something like we had 1/2 plus 2/3. How did we force those to have a common denominator? We multiplied 1/2 by what? 3 over 3. And we did that because 3 over 3 is represented by what? 1. 3 over 3 is 1, correct? So we're just changing how it looks. Now, that's what you're going to do today. Now, you're going to use those calculations off of that measurement sheet. Okay? How could you write me a fraction using 1 inch is approximately 2.5 centimeters? Somebody give me a fraction using those 2 numbers. 1 inch over 2.5 centimeters. Awesome. Now, because I'm saying approximate, we're going to treat that those are so close that they're almost equal. So we're saying that's going to represent as close to 1 as I can get. Okay? Now, is there another way that I can write that fraction and it still be considered 1? What? 2.5 centimeters over 1 inch. Both of those represent 1. Now, sometimes you have to decide which one you want to use. And here's how you decide. If I said 3 inches equals blank centimeters. Okay, write that on your paper because this is going to be an example that you're going to have to look at to do your classwork and homework. Yes. So you're going to start with what you have. So 3 inches, and now I'm going to multiply it by a representation of 1. So now I've got to choose. I'm going to either choose 1 inch over 2.5 centimeters or 2.5 centimeters over 1 inch. Now, I want centimeters as my answer, correct? So what word do I want to disappear? So if inch is on top, where does inch have to go for it to disappear? Bottom. So then centimeters got to be on top, right? So which one of these am I going to use? I'm going to use my 2.5 over 1. Now let's think about this. My inches cancel off, and I'm left with centimeters. My words match up, right? Let's do the math. That tells me I'm multiplying. So what's 3 times 2.5? Well, 2.5 is almost like a quarter, so 3 of them would be what? 7. So 7.5. And what's 1 times 1? And what's 7.5 divided by 1? 7.5. So my answer is 7.5 centimeters. Now, let me explain. When you go from a larger unit to a smaller unit, you multiply. Okay? Because a minute ago we went from an inch to a centimeter. A centimeter is just like barely the tip, like the little bitty part of your fingernail. I mean, centimeters are like really small. Okay? So an inch, which would be like the first knuckle of your thumb, versus like a centimeter, which might be about the width of your pinky. Which one's bigger? Inch or centimeter? Inch. So I'm going from a larger unit. I now have 3 of these, and I'm going to a smaller unit, so I'm going to multiply. So what do you think is going to happen if I go from a smaller unit to a larger? You're going to divide. And now we're going to do one of those. Okay? Very good. All right. So let's say I have 42 centimeters and I want to go to inches. So to show your work, you're going to put in 42 centimeters. I'm going to erase that because I made a mistake there. 42 centimeters, and I'm going to times it by something, and I'm going to be left with inches. So what do I want to disappear? So he's going to go where? That means inches goes on top. So how many inches equals how many centimeters? 1 inch equals 2.5. Where did I get that? I got that off this chart. Okay. Now, what happens to my centimeters? And now look at my numbers. 42 times 1 is, and 1 times 2.5 is. Now what's 42 divided by 2.5? Y'all may have to do it. So 42, let me extend my paper so I can have room. 42 divided by 2.5. I'm going to move my decimal over. How many times will 25 go into 42? We'll subtract. I get a 17. Bring a 0 down. How many times will 25 go into 170? 6. That's 150, right? Subtract. I get 20. Bring down another 0. How many 25s in 2? 8. So what's my, how many inches? 16.8 inches. Yep. First thing I want you to do is I want you to write the two fractions comparison between a foot and centimeters. So I want you to write the comparison between feet and centimeters. So we had 1 foot is approximately 30 centimeters. So write that as two fractions. it as a fraction, and you have two of them. Fill in the numbers. Or so now line up the numbers. How many feet? 1. And how many centimeters? So how many centimeters? And how many feet? There's my two fractions. Okay, so that's I'm going to use one or the other, depending on what I have. Yes, ma'am. Do what now? Okay. So now let me ask this question. If you have 2.5 feet, how many centimeters are you going to have? Do the math on your desk, at your paper, and then we're going to talk about it. Do you not have a writing utensil of your own? Well, the next time I'm going to ask you to just hold his hand during class. Okay, so quit. That's what I want you to do. Do you know where the bathroom is outside the gym? The handicap bathroom? Okay, so go to the handicap bathroom. Okay, make sure nobody's in it first. Knock. Riley shouldn't be in there. Knock on it though. If nobody's in there, open the door, and as soon as you open the door, there's a cart that has that burgundy basket that has calculators in it. Will you bring them to me? That might be nice to me. Maybe. No, he's fine. Alright, who wants to explain to me what I'm going to multiply? Kendall. What'd you put on top? What'd you put on bottom? Huh? 30 what? Okay. And what'd you put on bottom? Nope. What's my fraction? If you put centimeters on top, which one of these am I going to use? 30 centimeters over 1 or 1 over 30? 1 foot. Thank you. Now, what cancels off? My feet cancel off. And what am I going to do between these two numbers? Multiply it. So what is 30 times 2.5, Kendall? $60. 7. Did you move your decimal out right? 75. Oops. 75 centimeters. That's all we should have, okay? Let's do another one. This time, let's say I have 52 centimeters, and I want to go to feet. So do that one. Will you go around and give everybody one of those black calculators that are alike? And before you leave, I need these back, okay? Sorry. When you divide, I want you to go at least to the 100th place, which is how many places in the decimal? How many is the 100th? 2. So go at least 2 places. stomp on it if you want to. Alright, so Rachel. You're still using the comparison between foot and centimeters. Alright, so do it quickly. 30 seconds, and you're going to start and tell me how to do it. 52 centimeters equals blank feet. Look at some of your other problems that we've done. Alright, so Rachel, what units am I going to use between centimeters and feet? So 1 foot over 30 centimeters. Okay, so what happens to my centimeters? Okay, so that's good, right? Now, we know 52 times 1 is, and if I put that over 1, we know 1 times 30 is. Okay, now my problem looks like 52 over 30, which means 52 divided by 30. So if you use your calculator, what you get? I just gave them to you to hold. So what is 52 divided by 30, Rachel? Okay, 1.7. Okay, so stop. I want 2 places. So 1.73 feet. Okay. Questions? What? Where did I get 1? Which one? This one? Or this one? This one? Put it on my customary sheet right here. When I look at 1 foot, that's approximately how many centimeters? Okay, and if you remember, we wrote that fraction in 2 different ways. We wrote it this way, and we wrote it this way. Now, it depends on what we have, on which one we're going to use. Well, they gave me 52. And I can make any whole number a fraction by putting it over. Okay, so see, we're still using some of that knowledge from our fractions, okay? So now at this point, then I'm just going to multiply. And divide. Okay? Alright, let's do another one. 1 mile equals approximately how many kilometers? 1.5 kilometers. So make 2 fractions right now using that statement. Make me 2 fractions. So Austin A, what's my first fraction? Don't tell it to me. One what? 1 mile over kilometers. Okay, that's 1. Okay, Austin B. Austin B. Tell me the other one. Tell me the other fraction. Okay, if this is the first one, what's the only other way it can be the second one? Make a guess. Olivia, lean up and whisper and tell him. Maybe he might hear it. I could read her lips and I heard her, so she's right. correct. Okay, so there's my two fractions. Okay, so I'm going to use one or the other, depending on what I start with. So if I start with 3 miles equals blank kilometers, solve that using one of those fractions. I'm telling you now, I'm giving you 3 miles, and I want to know what's the equivalent to kilometers. And it's odd. You're going to use one of these two fractions. Okay, well, let's do less of this and more paying attention. You got your calculator in front of you. Got it? All right, Brian. Which fraction am I going to choose to use to multiply there? Over? Over what? Okay, am I using this fraction or this fraction? One what? 1 mile. Now, what happens to my miles? They cancel out. So now what am I going to do between these numbers? They're both on top, so what am I going to do? I'm going to multiply them. So what's 3 times 1.5? 4.5. And if you have to see a fraction, 1 times 1 is, and 1.5 divided by 1 is 1.5, right? So if you got both ones on the bottom, you basically can just like let them disappear. Okay? So it's 1.5. So let's do one the opposite way. Let's say I have 32 kilometers equals how many miles? So I'm going to use one of the fractions that I just had. So you may have to look at it. Now your first step should always be to write it down, show me what you're going to multiply it by, and then you can pick your calculator up. You don't need your calculator until you show me those steps first, okay? Yeah, you have to use the fraction that corresponds to my kilometers and my miles. All right, Lily, what am I going to multiply 32 kilometers by? Okay, so 1.5 kilometers. All right. Now what? All right. Okay. Okay. Okay, and what do you get? That's correct. Yes. I wouldn't, because you got a calculator in front of you. Yeah, if you didn't have a calculator, you could reduce and simplify. Yes. Okay. But in this case, 32 over 1.5, you're actually going to have to divide with your decimal. Well, it depends on what you have. In this case, we're going to divide. The last case, we multiplied. Okay, I think it's just the wind because we got the forensics people's in and out.
Are we allowed to use our calculator?
Yes. Okay, because you're going to get such wild figures. Okay, and not for sure how many decimal places and stuff. So I'm okay if you use your calculators at home and here. But this is what I need to see. So that calculator really does nothing for me. It gives me that final answer, but it doesn't show me what you're multiplying by. So you've got to show me on paper what you're multiplying by or dividing by. Okay? Then you can, the answer doesn't mean as much to me as the step to get there. Okay? All right, let me ask this one. Let's say I have 32 ounces equals how many grams? So the first step that you need to be thinking about is making that fraction comparison between ounces and grams off of this sheet. Then, what are you going to multiply by? No. If it goes to a decimal, then it's going to be, go to the second place. Okay? Your answer is what I'm assuming you're asking me, right? Alright, so Miss Autumn, walk me through this. So we're going to take 32 ounces and multiply it by what? What was my fraction here? Ounces on top? It's on the bottom? I don't know, you tell me. What is it? Why bottom? Because they've got to cross out. Very good. Alright, so if ounces are on the bottom, what has to go on top? Grams. And how many grams are in 1 ounce? 28. Okay, so now what's happening to my words ounces? Okay. Now what am I going to do? Times. So what do you get? And 1 times 1. And 57 divided by 1. So my answer is 57 grams. Yes. That doesn't seem right. Yeah, that's not 57. 896. Multiply yours again. 32 times 28. So my answer is 896. Questions? Yes, sir. No, you start with 32, because that's what you have. Okay? No, you're going to divide whatever the number is. Like we had over here a minute ago, you're going to actually divide. Okay? Y'all feel good on this or not? You can do another one or two? Okay. Alright, let's say I have...
May I have your attention? This time we are ready to have our presentation by our author. If fifth grade class would please come to the auditorium, and also the following sixth grade class. Miss Debbie Jesse, Miss Music, and Miss Turner.
Who are y'all?
And sixth grade will remain in
Miss
the
Music.
period you're in until after the program. Thank you.
Yes, that means more mouth! Because he didn't call for y'all just now, right? Oh, Miss Music? Alright, so stop where we're at. We'll come back. Okay, what is the fraction that I'm going to use when I multiply 15 pounds by something to end up with kilograms? What's that fraction going to look like, Dante? 1 what? Over 2 pounds. Okay, now what am I going to do, Rachel? Okay. Okay.
Hunter Tilly to the office.
And then, that is correct. Okay. All right, here's another one. Then I'm going to let you start on your homework. Yep. Well, actually, you're going to get 2 sheets, so you'll get your classwork and your homework. Okay. I want you to do... I did. I was thinking of one. I'm sorry, my line's crooked there. One what? What's my unit? 1 inch over 2.5 centimeters. What happens to my centimeters? They cancel out. And so what do I get on top? What do I get on bottom? It should be a 32. What on bottom? 2.5. And what do you get when you divide 32 divided by 2.5? 12.8 inches. That's the answer. Okay?